Hi everyone. Agility Robotics is a 10-year-old robotics startup founded in Oregon, and our focus is on building humanoid robots as a service. Our robot, Digit, is a highly autonomous robot capable of hours of continuous work, performing complex combinations of skills in fully defined workflows. Today, Digit's working in logistics and manufacturing facilities around the world and really focused on fulfilling physically demanding and tedious jobs. So we work with roboticists and software engineers and mechanical engineers on a daily basis. We were both pretty excited to come to SREcon, pull the covers back a little bit on some of the cloud systems that we get to work on and that we use to manage and make robots work in the field. And since we both work in platform engineering, we tend to think of things in terms of platforms. No matter how autonomous Digit might be, managing and tasking and planning the complex work for a fleet of robots means that we always need to be able to remotely communicate with it. That means that Digit we can think of as really a node in a distributed system, and it's a node that moves and often is intermittent in its communication. Every Digit runs a pretty hefty amount of compute along with a full suite of sensors and actuators and subsystem processors. And so to integrate and orchestrate all of that, we really need reliable management to be able to communicate with lots of different software components and configurations and policies. And all of that is really pretty straightforward when you're just dealing with a small set of robots in one or two places. But as we scale out and we're starting to build fleets of robots, we need to be thoughtful about how we design our systems to manage and coordinate wherever they're located. So in addition to all the work that goes into making Digit itself work, we're building multiple cloud-based platforms which aim to help our customers and our solution engineers manage the robot work effectively, but also help us manage the fleets of devices at scale. So we want to talk about two of the different platforms that we work on to give you a little picture of that. The first is our fleet management platform, ARC, and that's what our customers and our support engineers use to manage the work and the workflows that our robots do. And then we'll talk some about our device management platform, which allows us to manage the life cycle and configuration of all of our devices remotely.
All right, so we will focus a bit more on ARC, our fleet management platform. ARC is not an acronym, I just found out. I thought it meant Agility Robotics Controls, but it's just ARC. So as you can see here, from the cloud view, it looks like any traditional SaaS platform. It behaves like any distributed control plane at the edge. We are building a tool that uses multi-tenancy, single tenancy, a web UI, APIs, a workflow engine, standard observability, a CI/CD deployment, and like we all know, on-call. So when does ARC stop being a SaaS? Well, when the control plane actually starts talking to these robots. There's intermittent connectivity and edge buffering, right? We can't assume a constant stream. Connectivity is a luxury. For edge buffering, we have to leverage quality of service levels, QoS. You don't need a 100% guarantee that every I'm okay heartbeat arrives, but you must guarantee the I hit a wall notification does. We use MQTT because it's lightweight and the session is our secret sauce. Partition state, that means there might be a dual truth problem. The cloud thinks where a robot is, but the robot actually knows where it is. So let's focus in one particular area that we are generally aware of when we're working with distributed systems, networking. Network is our failure domain. When robots require fleet management, telemetry tracking, cloud processing to complete its tasks, it stops being a standalone machine. It becomes a very heavy and expensive moving IoT device. To top it all off, we deploy these IoT devices into the worst possible radio frequency environments. For example, we have high interference, multi-path and fading, and dynamic and unpredictable conditions. So, and also the challenges of physics, right? Forklifts, racks, and inventory can act as a dynamic Faraday cage, handoffs between access points, roaming drops packets, and latency and throughput. Most enterprise networks optimize for a high throughput, not latency. Robots need both, but we must prioritize latency. But we have some amplified edge realities. Like I said, movement amplifies network instability, roaming across these access points, latency shifts minute to minute, Wi-Fi instabilities, just like presenting in a conference, observability under partition, which means telemetry gaps, delayed event delivery, unknown robot state, and false healthy signals. And lastly, being cloud dependent, it equals your blast radius. When these robots are too dependent too heavily on the cloud, a partition will lead to a stalled workflow, maybe physical blockage, or even human operator impact. With this in mind, we cannot really engineer a flawless wireless network in this dynamic physical space. We have to design the system to expect the network to fail. So we prioritize rapid detection and recovery over exhaustive failure prevention, because this environmental variability, RF instability, and physical interaction makes many failures unavoidable. For this, we use some common SRE practices, such as defining a robot SLO, detecting faster MQTT, correlating alerts and automating paging, and reducing our MPTR. And now Ryan will talk to you about the other platform.
Yeah, so beyond managing the tasking and planning of work that digits do for customers, we send digits into customer workspaces where they're accompanied by a suite of other devices that are necessary to assist in getting the job done safely and quickly. So we have systems that handle safety, monitor charging, configure bridges for communication between other third-party integrations and even other robots. All of those devices need to be monitored and configured and updated and communicated with to make sure that Digit and Arc can coordinate with each other properly. But our customer sites, like Jeff said, are really challenging environments to deploy in and communicate with. Customers in these environments tend to have very restrictive network access and stringent security requirements. And the networks themselves are noisy, bandwidth limited, and have variable latency. So we really need to think about the set of capabilities that our device management platform needed and be carefully and thoughtful about it. So in terms of connectivity, we know we needed secure connections initiated by the device behind the firewall and able to transit the firewall back to the cloud. Provide just-in-time access for our engineers and support teams to be able to get to those devices when needed. Scope that connectivity for both machine-to-machine use cases and human-to-machine use cases, and be fully auditable and accountable so that our customers have confidence that only the right people are connecting to these systems at the right times. Our identity and access management for devices needs to make sure that we provide a unique global identity for each of the devices, and that identity is issued by us, tied to the hardware. That should be capable of time-limited and revocable access with extensible metadata so that we can do attribute-based control, and be capable of being interoperable with a standard set of authentication and authorization frameworks for other external services. Importantly, for the software configuration and management component, we need to do over-the-air updates for not only the OS and the software components, but also versioned configurations, policies, AI models, and calibrations, and be able to send all of that over the air. That whole system needs to operate in a declarative way while being self-healing and fault-tolerant. And finally, of course, we need observability that provides us visibility into system events and operations, provides the metrics and logs from all layers and all components on the device, incorporates traceability, and is close to real-time and resolution. So I'm sure a lot of that sounds familiar. We know we're sort of reinventing the wheel with a lot of set of these requirements. This is stuff that's been solved or is solvable with what we know from cloud-native technology and distributed systems, current standards, and especially best practices and lessons learned elsewhere. So we pulled a lot of those lessons in from our previous experience and roles and made those part of the requirements. And we've adopted and adapted as much as possible common and standard solutions to fit most of these requirements. Give you a little picture of what the architecture looks like in its current state. So we've decided to leverage a stripped down version of Kubernetes, K3s, that's installed onto each and every device on a read-only file system. It satisfies for us most of the basic change management requirements and gives us a lead into that over-the-air change management. We use a GitOps methodology coupled with continuous deployment to provide that declarative, eventually consistent, and self-reconciling state in terms of configuration management. We are using OCI images for everything on our devices. So every artifact provides us versioning and metadata, and we have a clear picture into what's running on the device at any given time. And then we use OpenTelemetry for gathering metrics and FluentBit for performant log transfer, providing data from top to bottom. Connectivity and identity management, we're leveraging the teleport service, which provides secure tunneling and full access controls and auditing, along with machine identity based off of 509 certificates, which gives us that easy integration to be able to do MTLS authentication and authorization from service to service. So that architecture now allows us to be able to update a configuration by making changes in source, in Git, committing a PR, having the continuous deployment system determine the difference in state, move that difference in state to the device, and then allow Kubernetes to take over and make the necessary system changes. What's nice about that is that we have the ability now to use a standard set of tooling in a pretty broad ecosystem, right, that's very dynamic and gives us that, along with our remote connectivity and our observability systems, a much easier way to investigate issues that arise in operations remotely, and gives us a much better streamlined developer experience when it comes to building and testing new features and capabilities on board the robot.
So, if you're interested in the industry, just remember that robots are just edge devices in a distributed system. The fact that they walk is incidental. SRE is what makes them operable. As you know, I'm just a messenger for these people as a manager now. That's Matt, Andrew, Ethan, Jenny, Jacinto, Alvin, Tennyson, Ming, Ryan, and the person that actually got us this spot, Rachel, who's probably running around in a marathon right now. Please don't try to poach them. I need them. And we are hiring. If any of these positions look interesting to you, there's many more positions as well in our career page. Just hit us up. Thank you.